So you are given the curve. The curve has the equation x square tan y is equal to 9, 0 less than y less than pi over 2. And the first step, you are asked to find out dy by dx. We are asked to prove that dy over dx is equal to negative 18x over x to the power 4 plus 81. This is what we are asked to prove in the first step. So anyway, we have to differentiate it to find the derivative. So what we are going to do is, before differentiating, I have to rearrange it. Okay, so this is now x squared tan y is equal to y equal to 9. Let me differentiate the whole, both sides. So this is now the first function, the product rule. First function multiplied by the derivative of the second. The derivative of the second is secant square y. Since it is of y, I have to write dy over dx plus. Now the second function times the derivative of the first. The derivative of the first is 2x is equal to derivative of a constant is 0. So now I can write dy over dx is equal to negative 2x tan y. I have to take this to the other side, divided by x square secant square y. Here x and x got cancels. So this is now negative 2 tan y over x secant square y. Now what we do, see, in this there is no tan y, no secant square y. There are only some values. See here, what we are given is x squared tan y is equal to 9. So I can replace this tan y with 9 over x square. Okay, so from this, x squared tan y is equal to 9, which implies that tan y is equal to 9 over x square. Now what about the secant square? How can we get that? We also know that secant square y minus tan square y equal to 1. Therefore, secant square y is equal to 1 plus tan square y. Here tan y is 9 over x square. So the square of that, 1 plus 81 over x to the power 4. See, somewhat we are reaching. So when we replace this with these values, this is equal to negative 2. Tan y is 9 over x square over x times secant square y is equal to 1 plus 81 over x to the power 4. This is equal to negative 18 over x square over x times x to the power 4 plus 81 by x to the power 4. So this is now x to the power 4 goes to the numerator. So this is negative 18 x to the power 4 by x cube, x times x square, whole divided by x to the power 4 plus 81. That is negative 18x over x to the power 4 plus 81. That is what we have to prove. Okay. Now in the second part, we are asked to prove that C has a point of inflection at x equal to the fourth root of 84. So to find the point of inflection, we have to find the derivative of that, second derivative. We have dy by dx is equal to negative 18x over x to the power 4 plus 81. So we are differentiating it once again or finding the second derivative, which is equal to 18 is a constant. Negative 18 I am taking outside. I'm writing it as the power. So x times x raised to 4 plus 81 raised to negative 1. I have to find the derivative of this one. That is equal to negative 18. I am taking outside. Okay. Now I'm taking it as the product rule with the product rule. So first function multiplied by the derivative of the second. What is the derivative of the second? We can use the power rule. So it is n, which is negative 1 times x to the, instead of x, I am writing it as x raised to 4 plus 81. This, the whole thing, I am taking it as x. So this to the power negative 2. And I have to multiply it with the derivative. The derivative of x raised to 4, which is 4x cube. Okay, now the second one. The second function multiplied by the derivative of the first function. The derivative of the first function is 1. So this is now negative 18 times. We have a negative x and a 4x cube. So this is in total 4x cube multiplied by x. So negative 4x to the power 4. This I'm taking as denominator. Let me write it as x to the power 4 plus 81 square. Now consider the second term. Plus 1 over x to the power 4 plus 81. Now if I take the LCM, this is equal to negative 18. Negative 4x to the power 4. I multiply it with here. So this is now plus x to the power 4 plus, no, I have to multiply this with here. Yeah, this with here. 81 over x to the power 4 plus 81 square. Now let us simplify this and see this is equal to negative 18. I have a negative 4x to the power 4 plus x to the power 4, which is equal to negative 3x to the power 4 plus 81 over x to the power 4 plus 81 square. So that is our second derivative. Now at the point of inflection, what happens? We have to check this is equal to 0. Okay. When this is equal to 0, and we are given that we have to show that point x is equal to fourth root of 27. We have to check with at fourth root of 27 whether this second derivative is equal to 0. So I put x is equal to the fourth root of 27 in the second derivative, that is equal to negative 18 minus 3 x to the power 4. Here x is equal to fourth root of 27. So I can write just 27. Okay. Plus 81 over again 27 plus 81 the whole square, which is equal to, see, 3 times 27, which is equal to 81. So negative 81 plus 81, which is equal to 0. So this is now 0. So we got d square y by dx square is equal to 0. Okay, now when x is less than, next what we are checking is the points to the left of this curve and the right of this point. The curve to the left of this point and the right of this point. So when x is less than this, so when x is less than fourth power of 27, when x is less than fourth power of 27, what happens? D square y by dx square. What is d square y by dx square? We got it as negative 18. Yeah, here it is. This one. When x is less than this value, here we will have d square y by dx square is less than 0. Okay, this won't be equal to 0. This value is less than that. So the whole value is less than 0. And when x is greater than fourth root of 27, d square y by dx square. Here this value will be greater than root of fourth root of 27. So the whole thing will be greater than 0. Okay, so on the both sides of that point, d square y by dx square is less than 0, and in the other side it's greater than 0. Hence, x is the point of inflection.